All right, so we're going to take a look today at exponential functions. So we're going to see that there are some multiplication and division patterns that are going to show up, and we're going to determine whether or not things are growth or decay, the functions, and we're going to look at domain and ranges. Okay, so the most important thing to realize is that we are no longer in linears. We are in nonlinear functions, so all of these are going to curve. Okay, all of these are going to curve. So take a look at these tables. What do you see as far as patterns? What do you see as far as patterns? So kind of think about that for a minute, and then let's go ahead and take a look at them on this next slide. So if I take a look at this first one, I'm going from 16 to 4 to 1, 16 to 4 to 1. So I see that I'm going from big to small, and I know that to go from 16 to 4, I divide by 4, and to go from 4 to 1, I divide by 4. So all of a sudden, that is a division pattern, okay? But that is different than our adding and subtracting that we saw in linears. Now, this one is going from small to big. So the 2 is small, the 16 is big. So this is times 2. Okay, this is times 2. So this is the type of pattern we're going to see with exponentials. And we've got two types. We've got an exponential decay, where things are going down. Okay, the data is going down. It's going to level off. And then we have exponential growth that starts low and goes up. Okay, starts low and goes up. And we're going to see that our functions look like this. They look like a times b to the x, where we have a power. We have an exponent that is the variable. And we also see it a times b to the x without the parentheses. Okay, it's the same thing, but they definitely have an exponent that's a power. Now there is two types of decays. We have one of them here where we see that it's starting up top and it's leveling out. So that's a decay. But we'll also see another one that starts high and goes low. So both of these are decay because they're going down. Now this one is going to be our division pattern. This one is going to have a negative, okay? That one's going to have a negative. Now an exponential, that is always going to go up. Now it can start wherever. So it might start lower than 0, but it's definitely going to go up. All right, so let's take a look at some functions, and let's see if we can figure out like what causes growth and what causes decay. Okay, so remember, grow is going to go up, decay is going to go down. So I'm going to go ahead and open up my Desmos calculator here. And I want the graphing one. And here's my first equation. So y is equal to negative 2 power of 3 to the negative 2 times 3 to the power of x. And I notice how it's starting up here at 0 and it's going down. So that one is definitely a decay. Okay, that one is definitely a decay. So what do you think causes the decay? What makes it go down? Well, it's this negative. Okay, that negative causes it to go down. Let's try the one under it and see what happens there. So if I change this negative 2 to a 4 and I change the 3 to a negative, that doesn't even look right, does it? It doesn't even look right. So this one is not either one of them. I can't have a negative in the parentheses. So my b cannot be negative because it doesn't know what to do with that. Okay, it doesn't know what to do with that. And we'll talk about why that is here in just a second. Okay, let's go to this next one. So we're going to change this to a 5, and we're going to change this one to a 0.75. Ah, well, I see that it started up and it went down. So this one is also a decay. Well, what makes that one a decay? I'm not really sure. So let's take a look at the one below it. So if I change this to a 2 and change this to a 1.2, that one's going up. So this one is a growth. So what's the difference between this one and this one? Well, specifically, it's the decimal. So if a decimal is less than 1, so remember 0.75, that's smaller than 1. If it is less than 1, it's going to be a decay. But if I'm more than 1, so I'm greater than 1, I am going to grow. Okay, I'm going to grow. I'm going to go up. If I'm less than 1, I'm going to go down. Well, does that hold if I have fractions? Let's see what happens. So if I change this to a 7, and I change this to 2 divided by 3, I see that it is going down. Okay, that's a decay. Well, what about 8/3? What's that going to do? So I'm going to change this to a 6 and change my 2 to an 8. And I see that that went up. What's the difference between 2/3 and 8/3? Well, that fraction is less than 1. 2/3 is 0.66666666, okay, or 66 repeating. So that's less than 1, whereas 8/3 is 1.3 or 1.67. So that's more than 1. So this one's bigger, it's greater than, and this one is less than. Okay, well, what if we just have positive numbers? What's going to happen? So if that's a 6, and let's just make this a 3, that's also a growth. Okay, so if I have y is equal to 6 times 3 to the power of x, that one is also a growth. So what are some things that I notice? Well, first of all, the first thing that I see that's going to be important is I see that a decay either has a negative number as the a, so the first term, or I see that the b, which is in the parentheses, is less than 1. So it's either a decimal or a fraction that's less than 1. Now, the other thing that's going to happen is that when I see decay, it's often going to be a division pattern. Okay, it's often going to be a division pattern. Not always, because sometimes I see that we have the -2 on the outside, so that's going to just change my numbers and make them negative. But if there's a division pattern, that's also another clear symbol that we're going to have a decay. Now, growth pattern is always going to be a multiply, and I'm going to have numbers that are bigger than 1, okay? So numbers that are bigger than 1 or greater than 1. So anything that's positive is going to be a growth. Anything that has a decimal like 1.2 or a fraction like 5/3, where the numerator, the top number, is bigger than the bottom number, is going to be a growth, okay? So let's just real quickly review, how do I put this in my calculator? So this is your Desmos graphing calculator. So I can do f of x, it's an f of x, and I can do an equal to, and if I have 2 parenthesis 3 parenthesis, now I can do my power with this a to the b, and I can put the power of x in there. Remember, that's supposed to be a variable, okay? Or if I don't want to use this keyboard, I can do shift and the 6 button, which is my caret, and you see how that moves me up too. Okay, so either one of those works. I can also do the same thing with a y equals. So if I change these numbers a little bit, we'll take a look at a different function. And remember, I can do shift x, shift 6, and then here's my function. So those are both growth functions, okay? But that's how you put them in your calculator. All right, so let's keep going. And let's talk about domain and range, okay? Domain and range. So when we have an exponential function, they have a tail. They kind of have like a flat area. So I want you to think about, like, if I take my highlighter and I kind of draw where this tail kind of bottoms out or maxes out, okay? I see that there's a limit to where it goes. And that is going to control my domain and range, okay? So I'm talking about, I'm either going to be greater than a number or I'm going to be less than a number, depending on whether it's growth or decay and whether it's going up or it's going down, okay? So let's refresh our memories in terms of what is domain, what is range. Well, domain is the set of x's, okay? And the range is the set of y's. So if I take a look at my function, there is some something that I need to realize. I need to realize that I'm using every single X. Like I have a number here, I have a number here, I have one here, one here, one here, one here, one here. It's going to keep going forever. So the domain is all real numbers. And it's always going to be all real numbers unless it's a word problem. Okay. And the symbol that we use is we sometimes use this double-legged R. That stands for all real numbers. That means I'm using all the X's, no matter what they are, the positives, the negatives, I'm using them. Now the range is different, okay, because the range is controlled by this tail. And if I take a look at this tail, I see that from this tail, I'm going up. So since I'm going up, I know that I'm going to be using real numbers, and it's going to be greater than. Okay, it's going to be greater than because I'm going up. Well, where's the tail? The tail's at 0. This value right here is 0. So that one is greater than 0. Okay, it's going to start close to 0 and it's going to go up. Now this next one, the domain, again, is real numbers. It doesn't change. It's always going to be real numbers unless it is a word problem. Well, this one goes down. Okay, it's going down. So I know that I have real numbers, but this time I'm less than, and the tail is at 0. Okay, the tail is at 0. So it's all controlled by where this tail is. Let's look at a few more. Okay, so easily I could answer all these domains because it's never going to change. I'm going to just put real numbers in here because that's not going to change. It's always going to be all real numbers, okay? Unless it is a word problem. Now I'm going to take my highlighter and I'm going to highlight these tails. So here's my tail. It's coming across. I need to figure out where that number is. So I'm highlighting the tail, looking at where it's crossing the x-axis or the y-axis because that controls my range, okay? All right, so let's make some decisions here on what's going on. So first of all, this one I see is going down. So if it's going down, remember I have two choices. I can use less than or I can use greater than. Those are my only options. So if I'm going down, I have to use less than. So I have real numbers, less than. Well, where's it crossing? It's crossing at -4. So my numbers are less than -4. What about the next one? I see that it's coming across and it's crossing at 2, and this one is going up. So I have real numbers, and we can write it out with real numbers. And that's greater than, because I'm going up, greater than 2. It is going up. Okay, hit pause, see what you can do with these next two. Okay, let's see how you did. This first one is going to be real numbers again. And it's going up, so I know it's greater than, where is it crossing? It's crossing at -8. Okay, it's crossing at -8. So that is where my data starts. It starts at -8 and goes up. Range on this next one, it's above -6. Above -6. Okay, so let's put this all together then. So we're going to make use of our Desmos calculator, our graphing calculator, and we're going to get some numbers here. Okay, we're going to get some numbers here. So I'm going to pull up my Desmos scientific calculator again, or my Desmos graphing calculator, and I'm going to clear those out, and I want to put in f of x equals -3 times 2 and power of x. Okay, so I see that's a decay. I'm going to go ahead and just make myself a note that that's a decay. All right, so we need to get values here. So I want to make a table from this. So I'm going to go to my edit list. I'm going to tell it to create a table. And you can see how it's giving me my numbers. So 0 is -3. And 1 is -6. And 2 is -12. And if I need additional numbers, I can just click down here. I need 3 and I need 4. Well, I see -24 and -48. Well, I definitely see a pattern. Okay, I definitely see a pattern. So let's go ahead and take a look at what's going on here. So I'm going from -3 to -6 to -12 to 24. I see that I am multiplying by 2. Okay, I am multiplying by 2. And that's important because I also see the 2 is in that parenthesis. So that matters. So my pattern of the y is multiply 2. Okay, the pattern of the y is multiply 2. Now, here's the cool part. The pattern and the growth rate, the b, are the same thing. Okay? So if the pattern is times 2, the growth rate, the b, is times 2, is the 2. Okay? It's the times 2. All right, now, the y-intercept. Remember, your y-intercept is where it crosses the y-axis. So I'm looking for this value right here, which means I need x to be 0. Okay, I need x to be 0. So my y-intercept is always going to be where the 0 is. Okay, where the 0 is. So that value is -3. So if I wanted to start graphing this, I have 0, -3. I have 1, -6. I have 2, 12. That's coming down here. And I know that from looking at this, it came from 0. So it's going to be up here at 0, going down. Okay, up here at 0, going down. And this is a curve. It's not a line. Okay, it's not a line, so it's got a curve. Now, domain, we already know that. It's all real numbers. It's all real numbers. And my range, I'm starting at 0. Remember, when you think about where that tail is, were the real numbers less than 0 because this is going down. Now, the two important things we need to pull from this as we look at this is look at your y-intercept. Your y-intercept is -3. See how that's right here? So my starting point, okay, my starting point is -3, and that's the first number that's in front of the parentheses or in front of my b value, okay? So that matters because that is my formula. I have a times b to the x. All right, let's look at another one. Let's see if we can kind of figure out what's going on with this one. And then we'll take a look at the graph and decide whether or not this is going to move up or down. Okay, so we have 0, 4, 1, 8, 2, 16, 332, and 464. So what is your pattern? How are you going from 4 to 8, 8 to 16, 16 to 32? Yeah, it's times 2. Okay, it's times 2. And we already said that if my pattern is times 2, then my growth rate is a 2. Okay, my growth rate is a 2. Now, y-intercept, remember we said you got to find the 0. Okay, we got to find 0. So if I find my 0, I see that we're starting at a 4. So to write my function, it's a times b to the x. So my a value, my starting point is 4. I am multiplying by 2. It has a power of x. So 4 times 2 to the x. That's the function. All right, so let's take a look if we can graph this. So 0, 4, 1, 8. Whoops, I put that one in the wrong spot. 0, 4, 1, 8, 2, 16. Remember, this is a growth. And what we're going to notice is that this is going to come straight up. So let's go ahead and put this in our calculator and see what happens here. So we can start with f of x equals and I think I have 4 times 2 to the x. You can see how it's down at 0 and it's going up. Okay, it's down at 0 and it's going up. So I did sketch it right. Okay, so then domain, again, all real numbers, never going to change. And if I think about where my tail is going to be at 0 and it's going up. So real numbers greater than 0. Real numbers greater than 0. All right, so that's what you're going to work on today. Reach out to us if you're struggling, and then tomorrow we're going to take a look at some other functions. specifically a division function. So if you need that for your homework today, then go ahead and go ahead and start taking a look at that next video.